All right, so this is question 9 on the problem set, and I think it's probably a good question to go over because it involves a differential equation, which can be somewhat tricky. So we're going to use separation of variables, and we're going to find a particular solution because we have an initial condition here. So the first thing I think I'll do is just, I'm going to zoom in on this. We're going to rewrite this as dy dx is equal to y squared minus x squared y squared. And I'm going to factor out a y squared so that I can actually separate the variables. So now what I can do is I can get the dy with the y squared, and I can get the dx with the 1 minus x squared. And that means dividing both sides by y squared and multiplying both sides by dx. So now we're ready for the antiderivative step. Okay, so you might think of a better way to think of 1 over y squared, the calculus-friendly way, might be think of it as y to the negative 2, so that when you take its antiderivative, you learn that it's negative y to the negative 1, which you can check. And the antiderivative of the right side would be x minus x cubed over 3, and we throw the plus c over there. And now you can use your initial condition whenever. Some people do it at this moment, some wait till the end. Why don't we just wait till the end? So I'm going to multiply everything through by negative 1 first. So I get y to the negative 1 is equal to negative x plus x cubed over 3. Now you can write negative c, but you could also just write plus c, because that c will be figured out once we plug in our initial condition. Okay, and now at this point, I would probably write it as 1 over y, right? Y to the negative 1 is the same as that. Maybe rearrange this a little bit. X cubed over 3 minus x plus c. Okay, and whatever algebra you use to get there is fine, but the key thing is if you want to quickly, I mean, what we're saying is the reciprocal of y is this, so that must mean that y is 1 over x cubed over 3 minus x plus c. Okay, we can plug in our initial condition at this point. So I know y of 3 is 1, so y of 3 is equal to 1 implies that 1 is what I get when I do 1 over 3 cubed over 3 minus 3 plus our constant. So I get 1 equals 1 over, that's 27 divided by 3 is 9, 9 minus 3 is 6, 6 plus c, and that implies that 6 plus c must be 1, or that c is equal to negative 5. Let's see if I can do a little bit better with space here. I'm just going to condense this. But in any case, we're basically there, so I see that y, my solution therefore would be y equals 1 over x cubed minus 3 minus x minus 5. So when you go look for that answer, you may not see it, which means it's in here in disguise somewhere. I would note the one that looks like that has the biggest shot of being right is B, which you can get if you, I mean, we need a negative 3 in the top, so multiply the top and the bottom by negative 3, and just hope that it pans out, which I think it does, right? So I'll times by negative 3 the numerator and denominator here of this expression. So I get y equals negative 3 in the numerator, and then the denominator I get negative x cubed plus 3x plus 15. And so let's go check. Is that? Yeah, that's answer B. Obviously, the x cubed and the 3x are in a different spot, but but it's answer choice B. So hopefully that helped.